Class, welcome back. Today we start our notes on 6.2. We're going to start nice and easy, a nice short video on our 6 trig functions, and then we'll move on from there. Alright, so our 6 trig functions you can see in the box right here: sine, cosine, tangent, cosecant, secant, cotangent. When we want to talk about the sine ratio or the sine function, we use sin. Don't say sin, just say sine. And then it's of an angle, so I put a theta. Sometimes you'll see it with an x. Okay, it doesn't matter. Sometimes you'll see it with a letter. All I want you to understand is that all of these ratios are taken of an angle. Okay, ratios taken of an angle. So if you see one of these if you see one of these functions, an angle always has to follow it. Alright, so moving right along, we know that sine is abbreviated as sin, cosine is cos, and tangent, probably the easiest one, is just tan, T-A-N, tangent theta. Alright. The three on the other side are a little less familiar. I don't want to necessarily say they're tougher to work with. They're just a little bit different. When we talk about cosecant, we use the abbreviation CSC. Secant, we use SEC. And cotangent is also somewhat easy. We just use the first 3 letters, cotangent of theta. Alright? So this is what you're looking out for when we're talking about trying to use any of these 6 trig functions. Alright, and we move down to this middle section, and this recall is very important. Alright, we have to remember what this means. This is basically saying that sine of theta is equal to the opposite over hypotenuse. Okay, so the way we really look at this, and some people will even write it a little differently. They'll write it like this: S O over H, C A over H, T O over A. So we remember. Sorry guys, this is an H. But what we need to remember is that these letters O, H, and A, they represent something on the triangle. Alright? Now in every right triangle, there is a hypotenuse. That hypotenuse is always across from the right angle. And that is the letter H. Now, depending on which acute angle we're using, so in this case, here's our theta down in this bottom corner, depending on where your angle is, that tells you where O and A go. And the reason is that O is always the opposite leg. Alright, there are 2 legs in a right triangle. One of them is opposite of an angle. One of them is adjacent. Well, let's think about this. Opposite, not this one. It's not opposite this angle. It's this one is opposite. So opposite leg, which then means, and hopefully you understand from English class, adjacent means next to. So here is the adjacent leg. Alright. So the ratios that you need to understand and remember here, and actually let me finish this. This is O, and this is A. So now we know that the sine is always going to be the opposite over the hypotenuse. So opposite over hypotenuse. Cosine, which we see is right here, A over H, means adjacent over hypotenuse. And lastly, tangent, opposite over adjacent. So op over adjacent. But again, every single time you see one of these problems and you see that you're trying to find the sine, the cosine, the tangent, you need to first label your triangle and figure out what is O, what is A, what is H. Alright? So make sure you have an understanding of how to differentiate between the opposite leg and the adjacent leg. Alright? Now, the reciprocal functions are a little tougher, but not too bad. Excuse me. Cosecant turns out that it is always the reciprocal of sine. Secant is the reciprocal of cosine. And then the easiest one is cotangent is the reciprocal of tangent. But what you need to understand here is if I have 1 over and then sine is already a fraction, if you write it like this and put a fraction down here, you're going to make a huge fraction. You're going to make a complex fraction, and we don't want to do that. So all we need to remember is what reciprocal means, or reciprocating means. And so what we're going to say is, well, cosecant is just the reciprocal of sine. So we come back over here. We see that sine is opposite over hypotenuse, and when we flip this, we get what cosecant is. It's going to be hypotenuse over opposite. Alright? When we do the same thing with secant, we see it's 1 over cosine, so we go to cosine and we flip it, which means this is hypotenuse over adjacent. And then lastly, if tangent was O over A, opposite over adjacent, well then cotangent is adjacent over opposite. Now the last thing I want to just kind of, it's not necessarily a trick, but you do have to kind of remember that cosecant goes with sine, secant goes with cosine, and I just think that it has to switch letters every time. So this abbreviation that starts with a C goes with the abbreviation that starts with an S. Alright? This one that starts with an S goes with the C, etc. Now this one hopefully we just understand tangent, cotangent, they're nice, they go together. Alright? Okay. When we move on down to our last example on this page, we want to find the following ratios. First thing you have to understand is look at what angle we're talking about. We're talking about angle P. That means you either need to put your finger at P, or you need to put an asterisk at P. Whatever you have to do, what I tend to do though, is once I have my angle, I'll mark it. I'll mark the O, the A, and the H. So for example, if I know that this is the angle that I'm working off of for all of these problems, well then this is definitely my H, and then opposite is across the way, and then the side that's adjacent, or right next to angle P, touching angle P actually I should say, will be my adjacent. And now I know my O, my A, and my H, and I'm ready to just quickly write all of my ratios. Okay? So, sine is opposite over hypotenuse. Opposite over hypotenuse. So, 20 over 29. I probably shouldn't write my fractions like that. I'm going to do better the rest. Okay, cosine is adjacent over hypotenuse. So, 21 over 29. Lastly, tangent, opposite over adjacent, 20 over 21. Alright? Now be very careful here. You guys now know that because cosecant and sine are reciprocals of each other, you can just take this and flip it, and that's fine. Just be aware that sometimes you're not going to have sine and you're going to be asked for cosecant, so you might have to find sine first. Alright, so here we can just say 29 over 20, because we already had sine, we can just flip it, 29 over 21, and 21 over 20. Alright, okay, let's keep going here. On our next page, last page, we want to put some information on our triangle based on what we're given and what we know. So we know that the sine of angle A is 2/7. So sine of angle A, here's angle A, and I know that sine is always opposite over hypotenuse. And actually I'm going to write that right here in the middle so we remember. So, TOA. And so now I know that sine has to be opposite over hypotenuse. So that means that my opposite leg has to be 2 and my hypotenuse must be 7. So if here's A, opposite's here, hypotenuse is here, and we're good. I'm not worried about the other leg right now. Alright, moving right along, tangent we know. Tangent is opposite over adjacent, and again we're working off of angle A. So opposite has to be 3, right? O over A, 3 over 4. So opposite over adjacent, 3/4. Okay. When we look at the next one, when I look at secant, I would just flip it immediately. I would know that secant goes with cosine, and I would just change this from a secant problem to a cosine problem. Okay, now I know that my cosine has to be root 5 over 7, and cosine is adjacent over hypotenuse. So here's angle A. Adjacent leg is right here, so this is my radical 5. Hypotenuse is 7, and I am done. Same thing I would say on this next one. So cotangent is 1/7, which means tangent is 7, but it's also 7 over 1. Okay, so be really careful with that. You have to remember that we probably want to keep this as ratios, since all of these are fractions. So tangent is opposite over adjacent. Here is angle C. They flipped on us, okay? So now we're working over here at angle C, not angle A. And we know, again, opposite over adjacent. So what side's opposite of C? Well, we're right over here. 7, 1, and we're done. Okay? Okay. Here we go. Last little section here. Use the triangles to write the ratios. Sine of A. We're over here at angle A. You could put a star, asterisk, whatever. Of course, then this is my hypotenuse, opposite, adjacent. And now I know that I just followed these rules. So sine is opposite over hypotenuse, 1 over root 5. Cosine, adjacent over hypotenuse, so 2 over root 5. Tangent, opposite over adjacent, 1/2. And then once you have those three, the other three are pretty easy. Okay, you could, in this case, you could put root 5 over 1, or you could put root 5, right, when you flip this. Beautiful. Let's see, root 5 over 2. And 2 over 1, or 2. Alright. Some of you guys may be asking, but Mr. Rabins, do I have to do anything with this? You know what? I'm letting you go with it. I know in calculus, in AP, they're not sticklers about rationalizing the denominator, so I'm not going to be a stickler on it. So if you want to leave it 1 over root 5, please feel free. If you were to rationalize it, just because I know some of you guys love doing that, we would have to multiply both top and bottom by root 5, which would then leave you with root 5 over 5. And both of these answers are more than okay. I will accept either. Alright? So there you go. Let's finish these up real quick, and then we'll be on our way. When we look at this next one, we're always talking about the 30-degree angle, so I'm going to mark that up so I know. And now I know that this is my hypotenuse, this is my adjacent, here's my opposite. And again, guys, we're good to go. We're good to go. So, opposite over hypotenuse, 1/2. Cosine, adjacent over hypotenuse, root 3 over 2. Tangent, opposite over adjacent, 1 over root 3. That is a 3, guys, sorry. I'm just going to rewrite that. 1 over square root 3. There we go. Alright. Again, you can stop there if you'd like. Cosecant, just remember, we flip them. 2 over 1, or 2. Secant, we flip cosine. 2 over root 3. And cotangent, we flip root 3 over 1, which is just square root 3. These are good to, especially 30, 60, 90s, 45, 45, 90s. We're going to be working with those specifically for the rest of the chapter. Those are big triangles that matter a lot when we talk about trigonometry. So numbers like these might be good to start memorizing, but we'll get there. We'll get there in a little bit. All right, last triangle. Let's see here. Talking about angle A, so I star it. Opposite, adjacent, hypotenuse, and here we go. 2/3. Cosine is adjacent, so root 5 over 3. Tangent opposite over adjacent, 2 over root 5. and we flip all of them. So 3/2, 3 over root 5, and to finish up, root 5 over 2. Alright, so hopefully this was a good refresher on sine, cosine, tangent, cosecant, secant, cotangent, and we of course will practice later in class. Have a good one. Peace.